In this video, we're going to be talking about how to solve literal equations, which we also call formulas. This is based on Blitzer's intermediate algebra for college students. So, section 2.4 talks about how to rearrange a formula. Now, so far, you've only had one x or one y or one set of variables, and then you say is equal to some constant. Well, in math, in science, you will notice a lot of times that formulas are real-world relationships, and they have a lot of different variables in them, okay? And they also can sometimes have numbers or symbols like pi or theta, those kinds of things. So sometimes you have to rearrange the formula so that the variable that you want is isolated, okay? So this is used in electricity, this is used in, like I said, in chemistry, this is used in physics, it's used all over the place, okay? Formulas and literal equations are the same thing. So sometimes, like the troopers use a certain formula to find out the speed of your car. When your trainer uses a certain formula for body mass index, and pharmacists and doctors use these formulas all the time for prescriptions, depending on your weight or your age or whatever, they determine how much of a particular medication they're going to prescribe for you. Okay, so basically what I want to do is look, there's all these letters here. So I can't really say W is equal to 10 or something because there's no numbers here in this particular one. But I want to rearrange it so that I solve for W. So that means I want W to be isolated, okay? So W, first of all, I'm going to just rewrite this as L times W is equal to A, only because it gives me my W on the left. Now, if this were a 2W is equal to A, how would I get rid of the 2? Well, that's easy. I would just divide both sides by 2. Well, instead of a 2, I have an L. So I can divide both sides by L. So I get W is equal to A over L. And this happens to be the area of a rectangle, which we'll use a lot when you're talking about, like, if you want to buy carpet for your house or whatever, and you know the length of your room and the width of your room, you can multiply those two together, and that tells you how many square feet or square yards or whatever of carpet you need. All right, so what about here? I want to solve for W. So I'm going to rearrange these again. 2L plus 2W is equal to P. I'm just going to switch sides just because I want my W on the left. All right, so this is being multiplied and this is being added. I kind of do the opposite of PEMDAS whenever I'm rearranging an equation. When I'm evaluating an equation, then I use PEMDAS, but when I'm rearranging, I don't know if you've noticed, we kind of do the opposite. So let's get rid of this 2L first. How do I know to subtract it? Because it's being added. Well, now this looks kind of weird, but you can't combine P's and L's, so you just have to put them next to each other. Now I'm going to divide this side by 2 and divide that side by 2, because whatever you do to one side, you have to do the same thing to the other. There you go. Now, this would be helpful if I knew the length and the perimeter of a particular rectangle or a garden. Maybe you measured, you know that there's so much fencing around your garden and you know the length, but you can't get to the width because there's a tree in the way or a pool in the way or something is in the way and you can't get over there. You can figure it out by doing this formula. Okay, what happens if you have something like this, okay? So this is how much it costs to rent a car. The total amount to rent a car is whatever the daily rate is, or weekly rate, for example, plus the price for each mile, the cost of each mile, like 15 cents a mile or 10 cents a mile or 25 cents a mile or whatever it is, okay? So that's the total cost. So you use that quite a bit. Like you walk into Avis and they're like, oh, it's going to cost this amount of money, plus we're going to charge you extra based on how far you drive it. So people use this all the time. All right. So we want to solve it for the mileage, how much they're charging. Maybe they gave you the bill and you're trying to work backwards to see what they charged you. Okay, so I'm going to put D plus PM on the left because the variable that I want to solve for, I want to be on the left. So I'm going to subtract D. This D minus D becomes nothing. I can't combine my T's and my D's, just like I can't combine X's and Y's. I'm still trying to get P alone, so I'm going to divide by M. Why am I dividing here and I subtracted here? Here I was adding. The opposite of adding is subtracting. Here I'm multiplying. The opposite of multiplication is division. And that gets rid of the m. Notice that sometimes when you cancel, when you subtract these two, they cancel. They become 0. You add 0 to something, it's the same thing. Here, m divided by m cancels. That means that when you divide something by itself, it actually becomes 1, and 1 times something is the same. So you can either add 0 or multiply by 1 to get the same answer. That's what cancel stands for. It's kind of confusing in math sometimes. Okay, so now I get my P is equal to T minus D over M. Okay? All right, what about this one? This is using electricity, or actually loan, sorry. The interest is equal to the principal amount that you put in times the interest rate times how long you want to take the loan out for. And so if you want to borrow a larger amount of money, or maybe your rate is larger, or you want to try to borrow money over a 15-year mortgage versus a 30-year mortgage or whatever for a longer period of time, your interest amount that you pay is going to be higher. Okay, so I want to solve it for P. So that means I'm going to put PR and T on the left. Now P is being multiplied by R, so to get rid of the R, I have to divide by R. P is also being multiplied by T, so to get rid of the T, I have to divide by T as well. So the R's turn into a 1. T divided by T also turns into a 1. And whatever I did to the left, I have to do the same to the right. So P is equal to the interest divided by the rate times the time. All right, I want you to try the bottom. Hopefully, you did well. I have confidence. All right, so now we're going to look at a couple more examples. Same process. We're just doing it over and over. To have a healthy weight, supposedly by the insurance company, you take whatever, I think it's however many inches above 5 feet, I think is this number. And then this is your weight divided by 2 minus 3 times however many, maybe it's inches over 5 feet is equal to 53. I'm not sure. You have to go back and look at that. But something along those lines. So we want to solve this for W. All right, so we want W to be alone. It's already on the left, so that kind of makes things nice. We have a subtraction going on and a division. We can add a little bit easier and not complicate things. So we have a W over 2. These guys, so that means W over 2 plus nothing, okay, is equal to 53 plus 3H. All right. Now it's being divided by 2. The opposite of division is multiplication. So I'm going to multiply this side by 2 and multiply this side by 2. 2 divided by 2 is nothing. 2 times 53 is 106, and 2 times 3H is 6H. So I can distribute the 2. I can't combine the 3H and the 53 because they don't really combine. Typically, what you want to do is put my letters before my constants. That's how we usually write our answers in math. All right, let's look at this one, solving this formula for X. So this is what we want to be isolated. Let's get rid of the by first. Okay, so these guys go away. I have AX is equal to C minus BY. Looks weird, but you can't combine C's and B's and Y's. So you go ahead and do it that way. X is being multiplied by A. Just like if you had a 3X, how would you get rid of the 3? You would divide by 3. Well, you would divide by A. You would divide by A. It's the same kind of principle. Okay? And my pencil went out. Okay? So we have X is equal to C minus BY over A. All right. Work on these two. Here are the answers. Take some practice, but I have confidence that you'll be able to take care of it. You'll do well. Stay tuned for linear applications, or what we call word problems.